we review the 5 steps for hypothesis testing, we note that step 1 is state the null and alternative hypothesis. We saw this in the previous video. Step 2, in which we will see in this video, we'll discuss the level of significance, also known as alpha. We will draw the picture and we determine the critical values. This will be followed by step 3, compute the test statistics, and we'll also compute the p-value. Step 4, we'll compare the test statistic value with the critical value, or we will use the p-value method to compare the p-value with alpha. And step 5, we will reject or fail to reject the null hypothesis and make a statement about the problem at hand, and also to support or deny the claim. So in this video, we will cover determining the level of significance alpha and drawing the picture and determining critical values. In step 2, the level of significance, also known as alpha, will be given to the students in the applications that are presented. Alpha has several meanings other than the level of significance. As we've noted in our previous discussion, alpha is also what's left over from the confidence level. We talked about the confidence level when we talked about confidence intervals, and we gave some confidence level that we normally use, such as a confidence level of 90%. We look at 90% and we ask what's left over. Well, 1 minus the confidence level, 90%, is 10%. Alpha also measures the risk associated with making an error. In other words, if alpha was 10%, then I'm taking a 10% chance that I am wrong, or I'm willing to be wrong 10% of the time. Additionally, you will find that alpha represents the probability of a type 1 error. A type 1 error is when we reject the null hypothesis, when the null hypothesis is true. If you go back into the PowerPoint presentation provided to you, you can select the link and you will find additional information on type 1 and type 2 errors. We will not cover this in detail in this class. In determining the level of significance, once we're given it to us, we don't have to determine it. We draw the picture and determine our critical values. So as you can see, our alpha levels, or our levels of risk, are 10%, 5%, and 1%, as noted with a confidence level of 90%, 95%, and 99%. So if we draw the picture, we know in this case we have 2 tails and 90% is in the middle. In developing our hypothesis statement in step 1, we know that 3 issues can come about. In each case, our null hypothesis is a statement of equality, while our alternative hypothesis is in opposition to our null hypothesis in the fashion of an inequality. So here we have an equality, here it's not equal. Here we have an equality, here we have less than. Here we have equality, and here we have greater than. So we can draw a picture associated with each one of these hypothesis statements. So we call this hypothesis a 2-tailed test. In other words, equal and not equal. Well, if it's equal or not equal means that it can be either more or less. So this provides us with a 2-tailed test of hypothesis. With a 2-tailed test of hypothesis, given our alphas of 0.1, 0.05, and 0.01, we can go to our z-tables, or rather go to the lower right-hand corner of our positive tables, and we'll see our critical values. So for an alpha of 0.10, our critical values are negative 1.645 and positive 1.645. With an alpha of 0.05 or 5%, we have our critical values are negative 1.96 and 1.96. And additionally, with a 99% confidence level, leaving us an alpha 0.01, we have negative 2.7575 and 2.575 as our critical values. Moving to the next hypothesis statement, in this case we're testing to see if the mean is less than 35. So if we draw the picture, we know that this is a lower tail test because the direction of the alternative hypothesis points in the direction of the tail. So if this points in the direction of the tail, then this is a lower tail test. And with the lower tail test, all of our shaded region is on one side because it's a lower tail test. Therefore, when we look at alpha and we look at the whole 10% is on one side, when we look at alpha and all of our area is on one side, and alpha of 0.10 gives us a critical value of negative 1.28. Whereas if we do a 5% alpha, we get a negative 1.645. And if we do a alpha 0.01, we get negative 2.33. Moving to the upper tail, we see that in this case our testing hypothesis says that the mean is greater than 35. So our testing hypothesis, the direction of our testing hypothesis tells us the direction of the tail, which is an upper tail test or right tail test. This is also called a left tail test. And so when we look at our area, well, we have the same values except that they are positive. So an alpha 0.10 is 1.28, an alpha of 0.05 is 1.645, and an alpha 0.01 is 2.33. So, given that, here is our table of values associated with our confidence level. Given our confidence level, we have our alpha values, and I included 98% to show you what happens. If we have a two-tailed test, here are our critical values. Here are our critical values, plus or minus, two-tailed test. Now, if we have a one-tail upper, as depicted over here, here are our critical values. So as you can see that, well, 5% is half of 10%, so when everything is on one side and it's 5%, well, we're going to get the same value, 1.645. And then here, 1% is half of 2%, so it's all on one side. Here is split, here's on one side, and then we get 2.33. Here's a table that supplements a table in the lower right-hand corner of your positive table on your Z distribution table. One note, when sigma is unknown or we have a small sample size, we have to use the t-distribution. And we discussed the t-distribution in the last chapter. We have to use the t-distribution in order to find the critical values. We still draw the table based on the number of tails, and the level of significance is alpha, and we have to use n minus 1 degrees of freedom.